Just give me 1 second. All right. Let's see. All right, so it's definitely hearing me. Turn that back off. All right, should be good. So relays and timers. Some of the trade terms that are I don't have anything highlighted, but some of them that are good to know. The armature is just the movable component of the electromechanical relay. Just need to note that. SCRs, we talked about SCRs at all. Silicone controlled rectifier, that's what's used in like a variable frequency drive. It's a switch that can operate insanely fastly and handle high amounts of current. Solid state relay, we'll talk about that. My first highlight is the first sentence on the page. A relay is defined as an electrical or mechanical device used for remote or automatic control of other devices or systems. Usually what you're using a relay for is you're controlling a relay at a lower voltage and controlling something or turning something on at a higher voltage, or you're multiplying your effect. If I turn a relay on, I can turn on or off several different things at once. So there's a couple different purposes for a relay. Third paragraph, first sentence is highlighted. A low power signal can operate a relay regardless of the power level. The relay is controlling the relay power level. The relay is controlling. The signal does not have to be the same type of power. That's what I said. Like a lot of times, like this relay, well, all this is going to operate on 12 volts, 24 volts AC. But some relays, I guess, yeah, the coil is 24 volt AC. But some relays can operate with 12 volt DC and operate something and turn on something as high as like 600 volts, like 600 volt motor or something like that. Electromechanical relays. So that's what you see on the board, or that's what I have. That's what I have in my hand. Flip it over to page 2. I'll give you the 2 highlights in this section, then I'll talk about them. First full sentence on page 2 is highlighted. Hybrid relays are a combination of electromechanical and solid state relays. And then a couple paragraphs down, I've got the sentence that has the blue highlighted contactors, or that sentence highlighted. Other terms used to identify control relays are contactor starters and power relays. So just looking up at the board, how this relay, this electromechanical relay, how it works is you have a solenoid coil right here. You have 2 wires that are going to the solenoid coil. You can see these black wires are going to the coil. So whenever I induce a current in a coil of wire, what do I turn it into? Electromagnet. So like so this is just, it's like a solenoid. Do y'all work on the electrical trainers at any point? Like with these. So this is just a solenoid. All this is, like, it has 2 wires coming out of it. All of it is a coil wire. When I pass current through this is just some type of metal, and it will suck it in there. Like, and it'll hold it in there tightly and then whenever I release energy, I can pull it right back out. So same thing with this. When I power this up, this pulls in, and you can see the contacts right here, they change state, or they change position. So when I power the coil up, contacts change state. This is what the contacts are connected to. Y'all can pass, this is called an ice cube relay. Pass this around and you can kind of look, it has a little sight glass window for the contacts. Keith, yeah, we never heard you coming in the welding shop. He's deaf as a bat. But look at the little red button on the front of this, or it has a little flag that flips up. That's called a force. Like you can force this thing to change state. So push that and look at the contacts on either side as you go. And you can kind of, I wish they didn't frost the whole thing, but you can kind of look in there and see the coil and stuff like that. But just pass that around and look at that. And you can have tons of different contacts. So this one has 2 different sets of contacts, which is fairly normal in these. But you can look at this one down here. This has 4 poles. So this one can switch a ton of different stuff. These are used a lot in industry. Just very simple devices. We'll talk about how it's called an ice cube relay. They call it a throwaway relay. These go bad, not super often, but often enough. Like they operate so much they can kind of get stuck. Like a trip. Like if you ever suspect one of these is bad, go up to it, hit it with the back of your screwdriver, and if it takes off, like if the thing starts doing what it's supposed to be doing, like the stuff inside of it's just getting a little corroded. And the thing about it is, like you can see the back of it, it's just plug in. Go get another one out of the warehouse, pull that one out, put the other one in, and hopefully it works. But usually, like your first thing I did was hit it with the back of the screwdriver, and usually that freed up. Sometimes, like anytime you have contacts that are switching state a bunch, anytime you're pulling stuff apart that has electricity flowing through it, it creates a little bitty arc. Like any kind of, like just any little arc, that arc produces pits in the, so this is just a single, this is a contactor, this isn't a relay. It works kind of the same. Like you can see the coil that's in the back of it, and then the 2 little terminals here, that's the 12 volts that powers up the coil, and then it'll pull in this plunger. This is the contactor off of my condenser unit for my house, AC condenser unit. So this is just a single pole, it's just connecting one thing. But pass this around, like the reason, like this didn't go bad, but my air conditioner unit's from 2008, and I'm just trying to limp it along so I don't have to pay 8 to 10 grand here shortly. But so this was $10 off Amazon for a new one. But take a look, like the contacts are right here on the front. Like you can push those in, but you can see it without, you need to shine like your cell phone light in there. You can see it, but you can see the pitting that happens. And the more pitting there is, the less smooth that surface is for the contacts, and the less contact it's going to make. So the less contact I have between my contacts, it increases my resistance, right? According to Ohm's law that we've been doing, E equals I R. If my resistance goes up, what also goes up? My current. And I don't want to run higher current through the motor of my compressor unit with all those pittings, so change it out for $10 and hopefully extend the life of that. And that can happen on these. What can also happen is it can weld 2 contacts together and they won't separate, and that's why I say pop it with the back of your screwdriver, and sometimes that makes it let go. Sometimes it doesn't, sometimes it doesn't work, sometimes it doesn't. But stuff can go bad in those. The armature return spring, that's this up here. You can't quite see it in that frosted one. That just, once power is no longer on the coil, that return spring returns that back to a normal state. Whatever that is. 111, read relays and switches. Excuse me. The sentence that splits the columns is an online test question. Read switches are often referred to as proximity switches because the switch is not required to actually contact the magnetic device or to be a component of it in order to operate. Online test question.
Which one? The one that starts at the bottom and then goes to the top?
Yes.
Okay.
Anytime I say splits the columns, that's what I mean.
I'm a little slow, my fault.
You should be good. General purpose relays. So that's two general purpose relays, and then I drew a line and pointed to that tan box at the bottom. So plug-in relays, general purpose relays, they're all the same thing. But I highlighted all that. Plug-in relays make troubleshooting and replacement of relays easier. Instead of having to connect and disconnect wiring, a new relay can be simply snapped into place. These are commonly referred to as ice cube relays. Down below that, write or throwaway relays. Ice cube relays or throwaway relays, or throwaway. I'll also say this, it doesn't say this anywhere in the book, but a lot of times with these ice cube relays, this is the base for that ice cube relay. So this is where the 8 pins go. So after you push this in, sometimes there's a clip on the outside of these that'll grab onto the sides of this to make sure that this is held in place. They are a pain in the butt to put on. Don't skip that step. A lot of people just throw that away, but that's causing issues for later. They're a pain to put on, but once you can figure out how to do it, like, you get better and better at it. But I say that because I quit putting them on and screwed myself and had to go work on that piece of equipment again. It was important. So I say that for my mistake. Make sure you put those on because it can cause issues, especially if it's on a piece of equipment that vibrates, right? Flipping the page. First full paragraph on page 4. First sentence is an online test question. A general purpose relay consists of an electromagnetic coil, contact springs, a contact armature, and the mounting. Up at the top right, first full sentence up there is also an online test question. Relays with coil voltages of 6, 12, 24, 48, 115, 230 volts designs are the most common. So you can see this picture is just a very basic, rough example of the inside of one. I have the signal coming from my control circuit that's turning this into the electromagnet or coil. Once this is powered, this armature will pull in and connect these contacts. Once power is released from here, the armature spring will act and these will open up. So are these contacts, are these normally open or normally closed?
Normally closed.
Oh. If there's no power on the coil, are they open or closed?
Open.
They're open, right? Because the spring, no power here, springs pull in and they're open. So this is a normally open circuit. Yeah. But you usually have more than one set. Come on, give me a better picture. So if you're looking at this one, these 3 pictures up here, you have options. So usually it's a double pull, double throw, which is the one that I pass around as a double pull, double throw. So that means I have 2 sets of switching mechanisms that can connect 2 different things each. So if I look on the side, my coil is connected to what 2 terminals?
6.
4 and 2.
7 and 2. See 7 and 2? That's the little symbol for the coil, right? So when I put power across 7 and 2, that's when those contacts will change state, right? and then I have a set of switching over here and a set of switching over here. From 8 to 5, is that normally open or normally closed?
Normally closed.
Normally closed, right? Because it's closed. And then 5 to 6,
Normally open.
no, not 5 to 6. That will never be. They'll never have 5 to 6. And then 8 to 6 would be normally open. That makes sense? And then you have the same thing on the other side. That's not supposed to be like that. That's supposed to be.
3 is supposed to be open.
Yeah, like that's. Yeah, 3 is supposed to have a gap right there. Does that have a gap in the book? Oop. Well, there should be a gap between 3 and the one coming from 1. Like 1 to 3 should be a normally open, and then 1 to 4 should be a normally closed. Does that make sense to everybody? So you have 2 sets of switching techniques. So you can turn stuff on and off with just turning off 7 and 2. Most of them, like they have on page 5, they have the different one, like the blade style. If I'm being honest, I've never seen one of those. Most of them are the octal style, the 8-pin. The octal style 8-pin is usually the most common that I've seen. Another thing that's inside of this is the shading coil. Let me see if I have a highlight on that. I don't think so. The shading coil. So you remember with alternating current, right? We're gonna go back to this. Alternating current, we talked about like it goes through a progression of positive voltage and negative voltage, right? Just going back and forth. At 3 different points right here, I'm at 0 volts, right? If you ever walked in to a plant or something like that and you hear like a humming noise around some contactors or something like that, that's because for very, very brief moments of time, there's 0 volts flowing through this coil because it's AC, and that those contacts, they're not opening up all the way, but they're opening up, they're chattering. Like that noise is chattering of coils. What a shading coil does is it eliminates that. Shading coil will allow that magnet to act more effectively and keep those contacts tightly together. So the shading coil does. Page 6, I got a lot of online test questions in this chapter. Second paragraph on page 6, second sentence is highlighted. The term isolated, when used to describe circuits, means that the maximum rated voltage of the same polarity may be applied to each pole of a given switch without danger of shorting between poles or contacts. Right-hand side of the page, first sentence of that paragraph is highlighted. Online test question. Throws are the number of different closed contact positions per pole that are available on the switch.
What's the first one, test question?
For both of those on page 6 are online test questions. So you can see the picture on page 6. I don't have any of these highlighted, but it wouldn't be a bad idea for you guys you should know what poles and throws are. Poles refer to the number of independent circuits within the relay. Throws are the different number of closed positions per pole. Single pole, single throw, single break, single pole, single throw, double break, like working your way through those. They're not the easiest thing, at least in my mind. It took me a while to wrap my head around what that meant. But if you read it a little bit, like you'll be able to understand what they're talking about. 113, control relays and instrumentation. Second to last sentence in the first paragraph of 113. Newer PLC technology does not require control relays as the output signals from the PLC are sent directly to the control device. When PLCs started coming out big time in the 80s and 90s, like everything used to operate on relays and timers, like relays and timers and contactors and stuff like that. And these, like, this is a big PLC, but those came out and it eliminated that. Like I could put the programming in this and tell stuff when to turn on and when to turn off independently. So these are, they're not going to replace all relays and stuff, just because of cost, I mean, this is tens of thousands of dollars, and that's a few dollars. But a lot of them have been replaced where there's big pieces of code and stuff that can be replaced because this doesn't go bad. Hard, like these cards that are in these PLCs, like these don't hardly ever go bad, not nearly as much as those do. Solid state relays. So you can have a solid state relay that looks like this, which has no moving parts. First two sentences of 120 or my first highlight, solid state relays or SSRs are becoming more popular because in addition to their size advantage, they offer a long operating life and no contact bounce. They offer higher reliability than EMRs or electromechanical relays because there are no moving parts. Key in on that, no moving parts in a solid state relay. The next sentence is a separate highlight. Current leakage and inability to handle higher loads are some of the disadvantages associated with SSRs. Another separate highlight is the next sentence. The devices are also sensitive to overvoltage spikes. So they actually use, for a solid state relay, like you have your power coming in on this side. Anybody know what this is the symbol for? It's a diode. More specifically, it's an LED, light emitting diode. So whenever power flows through this actually turns on a light, and then you have a photodetector on this side. And that's what works with a triac to turn this switch on or off. Right, so you actually, in the solid state relay, you'll actually have a light inside of here. Actually, I think it's right there. That will come on. And that's an actual part. No moving parts, but there's a visual part to these that work. But definitely good for like machines that vibrate and stuff like that. 121 on page 8. First sentence is highlighted. Both EMRs and SSRs are designed to provide a common switching function, but they're accomplish this in different ways. Page 9, still comparing the two. First full paragraph on page 9, last sentence is an online test question. The function of the spring is to cause the contacts to separate whenever the signal is removed from the electromagnet and the magnetic field collapses. They're talking about the spring in electromechanical relay. So that causes the contacts to separate after power has been removed from the coil. Next paragraph, second sentence is highlighted. The LED or light emitting diode accepts the relay control voltage and converts this energy to light energy. The right-hand side of page 9, I've got the heading of those bullet points highlighted as an online test question. The advantages of using SSRs instead of EMRs include the following. And then I highlighted the heading of every bullet point, keying in on the self-protection, which is this second to last one. So all these are important, but key in on the second to last one. But you have advantages of SSRs are improved reliability, noiseless operation, voltage drop is constant with time, low input requirements, self-protection, sealed housing. On self-protection, highlight the whole thing. The terminal shutdown designed into the SSR provides internal protection against the overload. Short-circuited loads may result in contact welding in a conventional relay, while the SSR simply turns itself off. You need to know that if something goes wrong with a solid-state relay, it will just turn itself off. An electromagnetic or electromechanical relay, remember I said those contacts can weld together and keep something on that you don't want on, that can be a big deal. Sometimes it's a light, sometimes it's a motor that doesn't need to be running, something like that. If something goes wrong with a solid-state relay, all it does is turn itself off and it doesn't work anymore. Page 10. Booster relay, like these pneumatic relays, repeaters, and boosters. These are even older than electromechanical relays. So I'm gonna give you the highlights on them and stuff, and they are useful for like very specific thing. Being honest, I've never worked on one, never seen one. What I know about them is from this book. So they might be out there commonly in some places, but I've never seen them, and I've worked a few different places, but I'll give you my highlights on them. 130, first sentence is highlighted, long sentence. Pneumatic relays or repeaters, transmitters, and boosters were first developed as a means of transmitting process signals located in the hazardous areas to remote locations, such as control rooms, without the extreme costs associated with explosion-proof enclosures. Force balance transmitter relays. First sentence is highlighted. The force balance principle is most commonly used in the pneumatic transmitter relays. The last sentence of that first paragraph in 131 is an online test question. Because nozzle back pressure is directly related to process pressure, the signal can be used remotely for indication, recording, or control. Out the side of that, I wrote most missed. That was I think the last time I gave this test, that was the most missed question. So make sure you got that one down. Page 11, booster relays. First sentence of 132 is an online test question. Booster relays are essentially air-loaded, self-contained pressure regulators. Booster relays are essentially air-loaded, self-contained pressure regulators. They're classified into three broad groups, and I've got the second two highlighted. You're gonna have a few questions come out of the second two bullet points. Ratio relays used to multiply or divide the pressure of an input signal. And then the last one, reversing relays that produce a decreasing output signal for an increasing input signal. Next paragraph, first two sentences are highlighted. One of the main characteristics of boosters is their high exhaust capacity. That is, the bleed rate closely matches the maximum output capacity. Page 12. Timers and time clocks. Second paragraph, last sentence of 140 is highlighted. Although each device works in a different way, all timers have the ability to introduce some degree of time delay into a control circuit. (141) dashpot timer relays. First sentence is highlighted. Magnetically operated oil dashpot timing relays may be used on voltages up to 600 volts AC. Essentially, what this does, it uses fluid flowing through an orifice. So you have a known viscosity fluid and you have a known orifice. It's like essentially it's like a timer for like a board game, except it's using oil, right? Like you flip a sand timer over, it takes a certain amount of time for that sand to get from the top to the bottom. This is the same, except it has like electrical contacts on it, and it has like an orifice and it uses oil instead of sand. Kind of the same thing. Third sentence is an online test question, 141. The magnetic field of a solenoid coil lifts the iron core against the retarding force of a piston moving in an oil-filled dashpot. Oh, it's not just oil, it's a piston moving through oil. What it is. That's not quite the same, but a piston moving through oil. Skip two sentences, and I've got the next sentence highlighted. If the piston is not allowed to make a full return, the timing is erratic. So if you don't let the piston go all the way back down, up, then it's not gonna make a full drop on the timer. These are used for like high current switching timing. That's about all I need y'all to know about those. Flipping over to page 14. Synchronous time switches. Anybody ever seen one of these? These are used quite a bit. They're used for like high voltage or high current switching for certain times. They do a lot of times sprinklers, sprinkler systems or security lights outside will use something like this. I'll give you my highlights and I'll talk about them. But these are synchronous time switches. 142 second sentence is highlighted. The term synchronous is used to describe such time switches because AC synchronous motors are used for the clock motors. Sentence that splits the columns is also highlighted. The contacts are usually self-cleaning and made of a special alloy to prevent pitting. They are rated to carry an inrush current 10 times their normal amperage rating without arcing or sticking.
Where's that at?
That's the two sentences that split the column on page 14. So bottom left of the page, the contacts are usually self-cleaning and made of a special alloy. They are rated to carry an inrush current of 10 times. 10 times is what you want to key in on. 10 times their normal amperage rating without arcing or sticking. Bottom left of 14.
Right above the control dial.
So if you're looking up on the board, like these have been used for a while. I mean, it doesn't look like they've changed their signage for quite a while. New graphic designer. But you can see, like if I zoom in on this, this has a time on it. So right now it's saying that it is 8 o'clock in the morning, right? And usually the goal of this is probably some type of light switch. Because you can see your manual switch down here and it's off. So right now the lights, if this is for lights, the lights are off, right? And then you have these two little, connection pins on the side. And they have different, you can't see it, but there's different length arms underneath them. If you look real close, this silver one says on, and then you can't see it, but this one says off. So this yellow dial spins with the time. It spins clockwise. So 8, 9 o'clock, moving on. And then once it gets to 6 o'clock, there's the arm underneath this will actually hit a mechanism on this and turn the contacts on. So the lights will stay on from 6 at night till midnight. Once this midnight tab rolls around, it'll switch it back off. Good, so this would be like parking lot lights for a business that closes 10, 11 o'clock at night. What I will say, there's a couple different things I'll say about this. These tabs suck, like they fall off all the time. And you constantly have to adjust them. I've taken pliers and tried to tighten them down. They'll still, eventually after hitting this thing so many times, they'll fall off. Whenever I worked at Goodyear, they fell off and we lost them. And this was for the sprinkler system out front of Goodyear, and Goodyear was big, like it was 52 acres on the roof, big building, big amounts of ground. The big boss went out of town, and he was manually switching the sprinkler system on and off every day. Asked me if I could do that while he was gone. So first day I did it, walked in. I got to work at like 4:30 in the morning. I got in, flipped them on, went upstairs to my office and forgot. Noon rolled around and somebody was walking around. I was like, anybody know why the front yard is flooded? Like, shoot. I went down there and turned it off and never said anything. But you gotta watch that if you're turning this thing on manually. But they're pretty easy to operate. The biggest thing people think is whenever they're setting the time on these is to unscrew this little screw right here and move this. That is not how you do it. Like make sure this sheet's not usually in there, but you can easily Google this. You can see it right here. Do not move time pointer, lift dial, turn and set. So you actually pull up on that dial and you can turn it to set the time. So you can see the inside of this. So you can see my two little pins and how they have different arms. And once they make it around here, they switch this, which turns this on and off. And this is just the synchronous clock motor. And then you have your contacts over here, or your contacts are on the back. Yep, solid state timer is 143. Sentence that splits the column, so all the way in the bottom left of 15. Most solid state devices use a resistance, capacitance, or RC network with a transistor and a silicone controlled rectifier, SCR, to provide the time delay and switching characteristics. So that's like, that timer is like this. Usually I try to get y'all on the trainers that use this, but this has like this is an 11-pin base, just similar to that ice cube relay. But what you can do with this is like you can spin the dial in the front, and I have different settings where I can set it to seconds, minutes, hours, and set it to different amounts of time. And you can use it as a time on delay or a time off delay. What I mean by that is like you can set this up to where you can hit start, and then it might have like a 10 seconds delay or something like that where the equipment's not going to start up for whatever reason. Same thing. You can also hit an off switch and it would keep it on. So like your car gets real hot. Like in the summer, your car gets real hot. You turn it off. You can still hear that fan going. That's got a time. It'll either have a timer or a thermal switch, but it might have a timer to say, let's keep this running for a while to cool the car off because it's not all liquid. That makes sense? That's all my highlights for this chapter. Any questions? I'd recommend reading through some of this, especially the stuff we keyed in on. These are used quite a bit. But we got it's just a 10-question test, but you've got a lot of online test questions. So make sure you hit those. But just have this done for class on Tuesday. I'll check your work, let you study for a minute, take your test, and you'll be out in the lab. Dorian, you ready for that makeup test? Yeah. Go grab a computer. Yes.